In this example, we're going to use the amount of change approximation formula to answer this question right here. Suppose that f of 5 is a function. Suppose that f of x is a function. F of 5 is 10 and f prime of 5 is 2. We're going to use these facts to estimate f of 5.1. So the formula we're going to be using says that for a function, f of a plus h is approximately equal to f of a plus f prime of a times h. So for this particular problem, we're told information about f of 5 and f prime of 5, which tells us that a is equal to 5 is the first bit of info we have. And we're told that f of a, let's write that as f of 10. Or rather write it as f of 5, which is the number that we care about. So f of 5 is equal to 10. F prime of 5 is equal to 2. Now, that's almost everything we'll be plugging in except for h. So h is how much a changes by. So we're going from 5 to 5.1, so h is equal to 0.1. So using all of these facts and plugging into that approximation formula, we're going to get f of 5.1 is approximately equal to f of 5 plus f prime of 5 times 0.1. That is, f of 5.1 is approximately 10 plus 2 times 0.1. So this right-hand side is equal to 10 plus 0.2, which is equal to 10.2. So putting it all together, we get that f of 5.1 is approximately equal to 10.2. In this example, we're going to be using the amount of change formula to answer this application problem. So here's the setup. We're going to suppose that the number of bacteria in a bottle is given by some function p of t where time is measured in hours. And we know that starting out, there are 10,000 bacteria. And we're also going to assume that the derivative of the function at 0 is equal to 1,000. We want to figure out how many bacteria will be in the bottle after 1.5 hours. Now, the formula, in terms of p, our function is p this time, says that p of a plus h is approximately equal to p of a plus p prime of a times h. So what are all the numbers? Well, we want to figure out what's going on when t is equal to 0. So that is our a. And we know that p of 0 is equal to 10,000. That's how many bacteria there are when we start out. We're also told that the derivative at 0 is equal to 1,000. That's the rate of change as soon as we get started. And then what's h going to be? Well, h is the change from when we start to when we want to end up. And we're told to think about this 1.5 hours later. So h is equal to 1.5. So plugging all this in, we're going to get that p of 0 plus 1.5, that's a plus h, is approximately p of 0 plus p prime of 0 times 1.5. That is, p of 1.5 is approximately equal to 10,000 plus 1,000 times 1.5. So that right-hand side is equal to 10,000 plus 1,500, which is 11,500. So putting all this together, we get that the amount of bacteria 1.5 hours later is approximately equal to 11,500.